Now when you see the next sum, we read it very carefully, see what is given over here. See the sum, two circles. Yeah, there are two circles. Now first of all, we have to see whether the radius are same or the radius are different. Radius are given to you or not. Let's check it out. What is given in the sum? There are two circles. Now what are these? C, that is what? O comma R, these are the coordinates given to you. And C, O dash comma S, this is another one. These are two circles. Okay, what else? Touch each other at point P externally. That means these two circles are meeting at one point, that is what? Point P externally. That's the external intersection. What is given to you? A line is drawn to pass through P intersecting two circles at point Q and R respectively. That means there is a straight line which passes through what? P and meet those two circles at point Q and point R. Now we should draw the figure first. We should imagine the figures. So let's go for it. Draw two circles. Okay. With center O and O dash. Yes, very good. These two circles meet at point P. Beautiful. You have done it. And from this point P, we'll draw a straight line. Yes, meeting at point Q on the first circle and meeting at point R on the second circle. Can you see that straight line? Q, P, R. Yes, it's a straight line. What else? What are you going to prove now? Prove that OQ is parallel to O dash R. So we have to prove that OQ is parallel to what? O dash R. So first thing is what? We'll join OQ and we'll join what? O dash R. Because we want to prove these two lines are what? Parallel. I hope you have done up to here. Yes. What is the other thing we can do? We can join OP and we can join O dash P. Have you done this? Yes. By joining this, what happened? We get two triangles. Which two triangles we get? We get triangle OQP and we get triangle what? O dash R and P. Can you see these two triangles? Yes. See, whenever you want to prove the lines are parallel, either you take corresponding angle properties or alternate angle properties or interior angle properties, some properties required to prove that lines are what? Parallel. Let's see what we can do in this sum. See, when you see that triangle OQP, can you see the radius of the same circle? They are equal? Yes. So what do we get? We get in triangle OQP, OQ is equal to what? OP. Why they are equal? Because the radius of the same circle. By saying this, what will happen? This triangle become which triangle now? Isosceles triangle. Because of isosceles triangle, the base angles become what? Equal. That is what I get. I get angle OQP equal to what? Angle OPQ. These are the two base angles of the same triangle. Let us go for assumption. Let angle OQP be equal to angle what? OPQ equal to what? A. A is just an assumption, any variable you are taking of what? Two equal angles. Now similarly, we move into a next triangle of the another circle. I am talking about triangle O dash PR. When you see this triangle O dash PR over here, we get O dash P is equal to what? O dash R. Why you get this equal? Because they are the radius of the same circle in that circle. So what do you come to a conclusion? Once again, the base angles are what? Equal. That is angle O dash PR is equal to O dash RP. I repeat once again, O dash RP. That is what? The base angles of that particular triangle. Okay. So from there what I get? Let's go for assumption now. What I get? Angle O dash PR is equal to O dash RP equal to B. Yes, that's what? The second triangle. Okay. Now one very interesting thing in this sum is what? See, there are two vertical angles, vertically opposed angles. What do you get? Angle OPQ. Where is angle OPQ? OPQ is equal to angle O dash PR. Can you see that? Yes. Now these are two vertically opposed angles. Are they equal? Yes, very much. What I get? A is equal to B. But also angle OQP is equal to angle O dash RP, which is also what? A is equal to what B? So these two angles become which angle? Alternate angles, yes or no? So with the converse of alternate angle test of parallel lines, I can say that OQ is parallel to O dash R. That's what I wanted to prove, and we have done it. Now the next sum which you are seeing is very important. Just see the sum. You will feel about it. See what is given to you. I am reading the sum. And pay attention on the figure which is given to you. By looking at the figure, see what you get. See what is given in this sum. In the adjoining figure, that means the figure which is given to you. What else? A circle is inscribed in the quadrilateral. That means circle is what? Inside a quadrilateral. Which quadrilateral? Quadrilateral ABCD. No problem. What else? Given that BC is equal to 38 centimeter. It's given to you that BC is what? 38 centimeter. Can you see the BC? Yes, it's one of the tangent. Okay, what else? QB is 27. QB is what? Once again a tangent but from a point. Okay, that's how much? 27 centimeter. QB is what? 27 centimeter. And we got DC is what? 25 centimeter. What else? And that AD is perpendicular to what? DC. AD is perpendicular to what? DC. That means what I get? I get angle D is equal to 90 degree. This is all the information given to you. What you have to find? Find the radius of the circle. Yes. Now see, what are the various radius in this circle? If I join OS, I'll get OS as the radius. Yes. If I join OP, OP is also what a radius of a circle. If I get any one of this information, my job is over. So either I can find OS or I can find what? OP. Let's go for a construction first of all. Join what? OP and OS. Yes, I am joining both the radius because they are not given to you. After joining, see what I get a figure. I get OSDP. I get what? A quadrilateral. In this, first of all, OS is what? Perpendicular on what? DC. Your radius is perpendicular to the tangent. I also get that OP is what? 90 degree. OP is what? Perpendicular on what? AD. So I get angle OPD is what? 90 degree. I also get angle OSD also what? 90 degree. And angle D is already given 90. So what about the fourth angle? Angle POS will also become what? 90 degree. Sum of all the angles in a quadrilateral is what? 360. Okay, that means I got a figure which is a quadrilateral and where all the angles are what? 90 degree. Later on I will prove it's what? A square. See how to go for it now. What is given now? BR is equal to BQ, that is what? 27 centimeter. BR is equal to what? BQ. Why BR is equal to what? BQ? Because tangent drawn from exterior points are what? Equal. They both are 27 degree each. Exterior point, tangent from exterior points are what? Equal. Okay, what else? Therefore, CR will be what? CR is equal to CB minus what? BR. CB minus what? BR. CB is how much? 38 minus what? BR, that is what? 27. So 38 minus 27, I'll get how much? 11 centimeter. So what is 11 centimeter? CR. Further, what else? Also now, CS is equal to what? CR. See the figure very carefully. CS is equal to what? CR. Why you can say this? Because tangents drawn from exterior point are equal. So what I come to a conclusion, therefore CS is also equal to what? 11 centimeter. Further, what I can get? I can get DS is equal to what? DC minus CS. Yes, see the figure once again. DS is equal to what? DC minus what? CS. That is nothing but 25 minus 11 centimeter. That is what? 14 centimeter. So what I get? 14 Now OP is equal to what? OS. Yes, OP is equal to OS. We have done this. Radius of the same circle. Okay. What else? Therefore, quadrilateral DPSO, or I can say quadrilateral PDSO is a square. Very important step of the sum. Quadrilateral PDSO is a square. How can I say it's a square? Because the adjacent sides are what? Equal. And each angle of this quadrilateral is what? 90 degree. So whenever a quadrilateral adjacent sides are equal and each angle is of 90 degree, that quadrilateral is nothing but what? A square. And because it's a square, so what I get? I get DS is equal to what? OS. Yes, each side of a square are what? Equal. So DS is equal to what? OS. Therefore OS is nothing but what? 14 centimeter. And what is OS? OS is nothing but the radius of the circle. That's what you want to find. OS is what? Radius, and radius is what? 14 centimeter. So we come to a conclusion that radius of this given circle is nothing but 14 centimeter. And the sum gets over here. As we look into the next sum, see what I get. It's a totally different type of sum. We are reading it. Just go for it. If all the sides, what's given, if all the sides of a parallelogram, I think you must be knowing what are the properties of a parallelogram. Okay, no problem. Let's move ahead. If all the sides of a parallelogram touch a circle, the circle has been touched by whom? By a parallelogram. Okay, what else? Show that the parallelogram is a rhombus. Yes, if the circle is touching all the sides of a parallelogram, we have to prove that parallelogram is nothing but a rhombus. Now there is no figure given to you. So it's basically all assumption. We have to think about a parallelogram and about a circle touching all the four sides of a what parallelogram. So to start with, what do we go for it? Let the required parallelogram be ABCD. Correct. And let it touch a circle in the points P, Q, R, S respectively. So now you got a parallelogram, you got a circle touching all the sides of a parallelogram. Yes, this is the figure in front of you. After, what do you want to prove? You want to prove that this parallelogram is nothing but a rhombus. Okay, let's proceed further. Let's start solving the sum. The first basic thing what you get from this figure is what? AP is equal to AS. Yes, see it very carefully. AP is equal to what? AS. Why do you get AP is equal to AS? Tangents drawn from exterior points of a circle are always equal. Similarly, what else I can get? I get BP is equal to BQ. Yes, same property. What else? I get CR is equal to what? CQ. And finally what I get? I get DR is equal to what? DS. All these four things which I've got from a common property. Tangents from a exterior point of a circle is always what? Equal. After adding them, what I get? I get AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus what? DS. Yes, this is what the addition of above statements. But see, AP plus BP is equal to what? AB. I repeat once again. See the figure carefully. AP plus BP is nothing but what? AB. Yes, so what do you think is correct? Go ahead on the same lines. What else we get? We get CR plus DR is equal to what? CD. Yes. The next third one, what do we get? AS plus DS is what? AD. And finally, what do we get from here? We get BQ plus QC is equal to what? BC. Further, what do we get? AB plus CD is equal to AD plus what? BC. Then, but AB is equal to what? CD. AB is equal to what? CD. So AB plus CD, so instead of writing AB plus CD, can I write AB plus AB? Yes, because AB is equal to what? CD. Okay, so finally what I get? I get twice AB is equal to what? Twice AD. And 2 will get cancelled on both the sides. So what I get? AB is equal to what? AD. Yes, and similarly what you can find? I can prove that CD is equal to what? BC. CD is equal to what? BC. So from above what we got? We got AB is equal to what? AD, and CD is equal to what? BC. So all the four sides are what? Equal. So in a parallelogram, when all the four sides are equal, that parallelogram is nothing but a rhombus. So finally we have proved that ABCD is nothing but a rhombus. And the sum gets over. The next problem is a very calculative sum. It's full of calculation. I would like to remind you one property of circle. That's a chord property of circle. Whenever two chords intersect in the exterior of the circle, what I get? Product of the lengths are what? Equal. See in this sum what is given to you. The figure is there in front of you. There is chord AB and chord CD. They are intersecting where? In the exterior of the circle at point X. So what I get? What's the property? XA into XB is equal to XC into what? XD. This is the rectangular property of circle. Plus there is one more property which is property of circle along with the chord and tangent property. That is nothing but XT square is equal to XA into what? XB, or XT square is equal to XC into what? XD. Depending upon the need of it, we'll use the properties. First of all, let's see what is in this sum given to you. XA is 2 centimeter. No problem. AB is equal to 6 centimeter. Fantastic. XC is 3.2 centimeter. What else? XO is 5 centimeter. Now this XO will be very useful when you want to find the radius. We'll see in the sum. What else? Calculate. That means what? Find. Find what? CD. So the first thing is what? Finding CD. Now see the figure very carefully. Where is CD? CD is a part of what? XD. Now I cannot find CD separately. What I'll do? I'll first find XD and XC with the help of XC and XD. I can find CD very much aram se. Yes, I hope you understood that. Let's proceed. Now what I'm using is the rectangular property of circle. How will I do this? XA into XB is equal to what? XC into XD. That is nothing but 2 into what? 8 is equal to 3.2 into XD. Further solving, what I get? 16 is equal to 3.2 XD. That is 16 upon 3.2 is what? XD. So 16 upon 3.2 is what? XD. That means 5 is equal to what? XD. So what is XD over here? 5. But I want to find XD. No, my question is what? Find what? CD. So how do I get CD? CD is equal to XD minus XC. CD is equal to XD minus what? XC. That is nothing but 5 minus 3.2. 5 minus 3.2 is what? 1.8. So what's the answer? 1.8 centimeters, nothing but what? The measurement of CD that was required as the first part of the sum. Now moving into the second part of the sum. Finding what? XT. That's nothing but what? A tangent. How to find xt? Very simple. xa into xb is equal to what? Xt square. Now that is nothing but what? 2 into 8 is equal to xt square. 16 is equal to xt square. Xt is what? Root of 16. Xt is what? Plus or minus what? 4. But geometric parts can't be negative. Are they possible? No, it's not possible. Geometric parts can't be what? Be negative. Therefore, xt is equal to what? 4. That is, xt is what? 4 centimeter. So you have successfully found a measurement of what? Xt also. See that last part, the third part of the same sum. Find the radius of the circle. Now we have taught you one thing. If the two chords are intersecting in the interior of the circle, then how to find the radius? Or if two chords are intersecting in the exterior of the circle, then how to find the radius? Over here, where are the two chords? Chords AB and CD are intersecting where? In the exterior of the circle. So what's the formula for that? Yes, the formula is what? XA into XB is equal to OX square minus R square. This is the formula when the chords are intersecting in the exterior. I repeat once again. XA into XB is equal to OX square minus what? R square. By putting the information into the formula, the values into the formula, what I get? I get 2 into 8 is equal to 5 square minus R square. 16 minus 25 is equal to minus R square. Minus 9 is equal to minus R square. Minus get cancelled on both the sides. 9 is equal to R square. Root of 9 is equal to what? R. Plus or minus 3 is equal to R. But geometric part once again can't be what? Negative. Therefore R is what? 3. That is, radius of the required circle is what? 3 centimeter. So we got all the three answers. I'll recall all the answers once again. What is the first one? CD. CD is nothing but what? 1.8 centimeter. XT. XT is nothing but what? 4 centimeter. And the last and the final part of the answer, radius is what? 3 centimeter. And the sum gets over. Now on the similar grounds, that means on a similar type, one of the same type of sum which you're picking up now. This sum is on the same lines of the previous sum. See the figure very carefully, you'll understand automatically. See what is given in this sum. There is a chord AB which get extended outside the circle at point T, and there is a tangent, that's what? TP. So it has got a chord and a tangent. Definitely we are going to use a property of chord tangent property. What's that property? TP square is equal to TB into TA. Let's see what information we got. That was a rough sketching of the sum. Let's go for the information given in the sum. In the given sum, we have to find TP if AT is 16 centimeter. AT is what? 16 centimeter. The entire length of AT is what? 16. And we have got AB equal to what? 12 centimeter. But for using that property, I want the information, I want the measurement of TB. TB is not given to me, it's missing. How to find TB first of all? So TB is nothing but AT minus what? AB. That is 16 minus what? 12. That will give me what? 4. So what is 4? 4 is nothing but what? TB. Yes, so I am ready with all the informations. TB is now what? 4 and TA is what? 16. I can find out TP very easily now. By using which formula? Yes, the same formula. What's the formula? TP square is equal to TB into what? TA. That is nothing but TB square is equal to 4 into what? 16. 16 fours is what? 64. So TP square is what? 64. But I don't want the value of TP square. I want the value of only TP. So TP is what? Under root of what? 64. That is TP is equal to plus or minus 8. But geometric parts can't be negative. Therefore TP is what? 8. That is what? 8 centimeter. So finally what do you get answer? TP is equal to 8 centimeter. That was required to be found out. And we have done it.